Hello and welcome to my channel. Today, what I thought we'd do, let me back up. The other day, I made a short video on putting a hole right through the middle of this T-slot. And I told everybody if they want to know what it's for, to come and watch this video. What it's for is to mount this on my rotary table. My rotary table is 12 inches in diameter. This is 12 and a half. I can't clamp it on. So I have holes here that I can bolt it into the T-slots on the rotary table. Why would I want to do that? I need to make some parallel spots here. This is all cast and I need to make some flat spots for parallels to go on here, or blocks, something to set this on. Why would I want to set it on something? Because I want to finish this table. Refinish, I should say. I started sanding on this thing. After I cleaned up the T-slots, all four of them, I started sanding on it with a vibrating sander, and it wasn't doing anything. There's some deep cuts over here, and I started working on that, and I said, well, what I'm doing here is making this on parallel. I'm just blending everything. And I can't have that. I don't want the table to be sitting crooked when it's on the drill press, on the tapping machine, I should say. So I thought, when I looked at it, it looked like they just used a big fly cutter that went all the way around. I want to do something the same. I don't want to use a big fly cutter. What I was going to do is take like a 1 inch or 3/4 inch end mill and just go around, have a pattern like that. But that's okay. It'll all be level and cleaned up before I paint all of this. Also, these holes have a double purpose. If I'm using coolant on the tapping machine, this has a trough in it. The coolant will go into the trough, into those holes. I plan on tapping them later, some kind of pipe tap, I'm not sure what size, and then put some tubing, lines, some kind of lines to a tank to retrieve the coolant. I was going to do that, but I thought, because I told everybody, you want to know what it's about, come to this video. So, that's what it's about. What I wanted to do today was, this is the rack for the table to go up and down. And if you remember, if you were here before, I changed the diameter of the column. I need to put a shim behind there of about 65 thousandths, 60 thousandths. This goes in here and goes the opposite way. The gear. This has to be up against the gear to move it up and down, or actually to move this up and down the column. I need to move this 65 thousandths, about a 1/16 of an inch away from the column. Anyone that was here before knows I'm doing that. Well, I went and bought some aluminum, 1/16 thick, 3/4 inch wide. Because I assumed this was 3/4 inch wide. It isn't. Let's see. Let's measure this a little closer. This aluminum is 7 $50. The rack is $670. It's closer to, what is that, 17 millimeters? Where is that on my 17 millimeters is, yeah, 669 thousandths. This is 17 millimeters. This rack goes into this slot, but this does not fit. So that's a problem. I need to bring this down. That's two things I have to do to it. I want to deform this to fit the back radius of this, the size of the column. But before I do that, I need to bring this down to 17 millimeters. How do I do that? I'm not going to file it. I'm not going to grind it. I'm going to mill it down. How do you hold something like that? I don't know if any of you are familiar with soft jaws. These are aluminum soft jaws. I've used them for a lot of different jobs. You see the different shapes in here. You close them up with a piece of shim stock in here, 2,000-3,000 shim stock. Close them, and you make the shape that you want to hold. You see in here there was a couple of different shapes. Well, I also made these so they're reversible. What I was going to do in one of the jaws, this is going to be my back jaw. It says front jaw on it, but that was for when it was the other way. Anyway, I'm going to turn it over, and I'm probably going to make a cut in here about 50 thousandths deep. This is actually 58 thousandths. That's a gauge size. I don't know, the 15, 16, 17 gauge. But anyway, put it in here. When I close this onto there, it will hold it. And I could just move it right along. That's what I thought I'd do today. Make a set of soft jaws and bring this down to size. Let's get over to the mill and I'll show you. I don't know how many of you've ever seen soft jaws, but what I'm going to do is remove my steel jaws here and replace them with these aluminum ones. What I'm going to do after I put them in is I'm going to touch off with this end mill on the top of my jaw. Go down 670 thousandths. That's 17 millimeters. I'm going to touch the front of this jaw with my end mill then and go in about 50 thousandths and just cut along here and make like a parallel for that material to sit in. Close my vise, and I should be able to just skim the top of this part or jaw, and my material will be the size. Now, I need to remove these jaws, so let's get doing that. All right, I changed out the jaws, and like I said, I want to touch off on the top of this. The best thing, or not the best thing, but one of the good things about soft jaws is you don't have to worry about touching off exactly. You touch, take a little bit of material, re-zero, and clean up the top. And that will be your zero. And that's what I'm going to do right now. Okay, touch. Let's zero this. Tighten the set screw. That's zero. All right, that is my new zero. That is my new top of my jaws. Now, what I'm going to do is lower the spindle 670 thousandths, 17 millimeters, because that's how high I want, or how thick I want that piece of aluminum to end up. Let's do that. That should be 670. I'm going to touch that end mill right on the front here. What I'm going to do, I'm going to move back 50 and take a cut. Let's do that. I'm not sure if the camera was on for the first cut, but then I took a cleanup cut at about 5 thousandths. So this should be 670 thousandths. I'm going to deburr it a little bit, bring my cutter back to zero, put my part in there, and just skim across here, move the part up, skim across, and just go for the whole part like that. I'm going to deburr this a little bit. I'm not sure if the camera was on when I took my initial cut across this jaw. I know it was on for, I took like a 5 thousandths cleanup cut. It was on then. Let me get a stone. All right, I'm going to bring this back up to zero. That's 70. 1, 2, 3, 4, 5, 6. Let's see. All right, I'm going to put my material in there. Still in the bottom, or take a file here and just hit the bottom and make sure there's no big burrs. I felt one there. I've got about 18 more inches than I need. Some practice material for when I'm putting that radius, forming that radius. Let's see. Okay, now, if everything works right, I should be cutting this down to 670 or within a couple thousandths. Let's do that. Bringing that cutter back to this side here, it would have been nice to have a rapid traverse. I guess I should measure that. This is 655, that's 15 thousandths less than what I was shooting for. I'm just going to move that right along. I think that'll be okay. I'm just going to move it over and keep cutting. I think this time I'm going to run it all the way to the end of the jaw, move it off the jaw, advance the material, and try to come on again. We'll see how that works. This is what I mean. I'm going to advance it here. Okay, let's see how this works. Yeah, that didn't work too bad. I'm going to turn this around. I don't have that much wall room. Parts running into the wall over there on that side. Let's see. Okay. I did that because now I have the last cut all inside the jaw here. Let's finish this. All right, let's go deburr this thing. Let's lay this up against that. You really can't tell that I'm 15 thousandths under. I don't know what I did over there. Now, if this was for a customer, it'd be junk. And I'd have to go buy more material. I think this strip cost me $9 over at Ace Hardware. I didn't want to wait for it, so I just ran over there. Actually, this Ace Hardware, it's a new one. It's over by the King Soopers grocery. And this is about the 4th or 5th time I went there. And the first few times, they didn't have anything. Imagine a hardware store that didn't have hardware. Well, it's mostly material. They have some material, but not the different sizes I wanted. I got online and I looked up that hardware and they said they had it in stock. They said they had 3 pieces and they did. I'll show you a little closer after I deburr this. What it looks like right up on the part that it's going to back up. You really can't tell that it's undersized. That's the one good thing about hobby machining. And you making up your own sizes. I think I'm going to change the blueprint. I decided to go 15 thousandths smaller than this here. See, now it's okay. Actually, in real life, I've had to call customers. Well, a few times for me, but mostly for the guys. You know, they made a mistake in programming. They run the part, and with aerospace, stuff was super tight. It'd be a couple of thousandths off. And it was rejectable. You can't just send it along. You have to do a complete report, check the whole thing. Now, you talk to the engineers. All the engineers powwow together and decide whether it's going to work or not. Probably more times than not, the engineer said it was okay. Although you usually are working with the same engineers and you kind of know the work that they have. This one, this engineer, I'm not an engineer, said it'll be okay. Let me get some Scotch-Brite here. Get a smaller piece. I think that's going to be okay. Here, look at this. That's going to be just fine. I mean, come on. Now I just have to find a way to smash that radius. Not sure how I want to do it. Here, it has to go into that slot there. Just like this. There was extra room, even for this piece. But before it didn't go in. It didn't want to fit. Fits now. With 15 thousandths extra room. So you see it goes in there. It doesn't look bad on the back of this. I decided I was going to do this here today. I'll tell you about this a little bit more. I was going to do that and I went, well, I bought the material, I should do this. I should make the tool to put the radius on. And for some reason I stuck this in. I go, I was going to buy 1 inch. I bought 3/4. I didn't have that much to take off. But I stuck it in there and it's like, holy cow. Good thing I didn't start forming it, because that would have really been a bitch to fix. Anyway, if you've never seen soft jaws, that's a poor example I just had. I don't know what I did wrong. I probably didn't measure correctly. And after I took my first cut, I said I have about 18 inches extra. I could have adjusted. But also, I knew that it didn't matter. But let me tell you about this. What I need to do with this is throw it on a surface plate and see where all my high spots are. I mean, there's a lot of high spots on this surface. I need to make some places where blocks can go. So when I bolt it down, it's all parallel. And then I can go on the rotary table and bring this all to a nice size. And then after that, I need to paint it all. Like I said, I want to make these into like little drains for cooling. So I have more to do on that. I have to make some forming tools. I'm really not sure how I want to do it. I kind of have some forming tools here. This radius is way too small, but maybe I could adjust that. Put it in my press and just press it. Like I said, I'm not sure. But you got a lesson in what not to do when you're building soft jaws. But soft jaws are the way to go if you're paying attention. It made this job a lot easier than trying to find parallels that thin to go underneath this. And it was fun. It was an easy job. Okay, I think this video is going to come to an end. So I'm going to have to say, until next time, enjoy.